Hi, 7th graders. We're on lesson 10.5, which starts on page 547 in your textbook. Our learning target is multiplying monomials. So a monomial is a number, a variable, or a product of a number and a variable. And some examples of monomials are, mono meaning one, so that means it's one term. So even though there's a variable and a number and an exponent in some of them, it's still just one term. So 7g to the 6th is a monomial. 6m, 5 squared x squared y to the 4th. n, 2 is a monomial because it's a number. N, again, is a variable, so it's a monomial. And n squared. So if we had like 2x plus 1, that is a binomial. That's not a monomial. So that's an example of not. So notice how there's two terms here separated by an addition sign. So when I say one term, it just means one batch of numbers, variables, exponents, whatever, but it's all together in one term. Okay, remember that a power has a base and an exponent. So we know that 9 times 9 times 9 times 9 is the same as 9 to the 4th. 9 is the base, and 4 would be our exponent. Important to remember the difference between the base and the exponent as we move forward talking about multiplying monomials. Okay, so exponents, just like up here, are used to show repeated multiplication. So if we have 3 squared times 3 to the 4th, we know that 3 squared is the same as 3 times 3. And we know that 3 to the 4th is the same as 3 times 3 times 3 times 3. And since they're being multiplied together, then we rewrite it as, so here's our 3 squared times our 3 to the 4th. So it's the same as 3 to the 6th because we have 1, 2, 3, 4, 5, 6. So 3 squared times 3 to the 4th equals 3 to the 6th. So notice that our base, which is our 3, did not change because it's still multiplying a bunch of 3's together. But our exponent went from 3 squared and 3 to the 4th to 3 to the 6th. So notice that if we just add our exponents together, we get our new exponent. And we can see that here. We have 2 3's, 4 3's, 2 plus 4 is our 6 factors, and we rewrite it as 3 to the 6th. So our definition for product of powers, or multiplying monomials, is to multiply powers with the same base. So remember, they need to have the same base in order for you to add their exponents together to get our new product. So an example, 2 to the 4th times 2 to the 3rd, our base is 2, has the same base, is 2 to the 4 plus 3, or 2 to the 7th. Same as a to the m times a to the n, we would get a to the m plus n. We add m and n together because a is our base. So our base needs to be the same in order for us to add the exponents together. Okay, that may be a note that you want to add on, is that the bases need to be the same. Okay, if we have 2 to the 4th times 3 to the 3rd, well, then we cannot do anything with combining our exponents at all because that would not make sense. All right, so here's an example. Find 5 squared times 5 expressed using exponents. So we know that 5 is the same as 5 to the 1st. So if we have 5 squared times 5 to the 1st, then we add 2 plus 1, and we get 5 cubed, or 5 to the 3rd. This is where it gets a little bit tricky and a little bit more confusing, so listen carefully. If we have negative 3x squared times 4x to the 5th, we are looking at, so they each have the same base. Our base is x for each. For each exponent, the base is x. But then each one is being multiplied by a different number. So this is where it throws us off. So we're going to pull out both of our coefficients, which are our numbers, -3 and 4, and multiply them separately. So these are going to be multiplied. Then we're going to pull out our base and our exponent and multiply those separately. So -3 times 4 is -12. And then we know that x squared times x to the 5th is going to be x to the 2 plus 5. So then our answer then is -12x to the 7th. So we multiply our coefficients, but we add our exponents. Okay? Confusing, I know. Okay, oh, and here's our little notes about that I explained. All right, so 9 cubed times 9 squared. We know that 9 is our base. And then because they both have 9 as a base, then it's going to be 9 to the 3 plus 2, which equals 9 to the 5th. All right, 3/5 squared times 3/5 to the 9th. Because they're in parentheses, it doesn't actually need a multiplication sign there, but I'll put one there. So 3/5 is our base. So we're going to go 3/5, and then it's going to be to the 2 plus 9, and I'm going to actually put this in parentheses. 2 plus 9 is 11, so it's going to be 3/5. Now we can put it in parentheses to the 11th power. So keep the base, add the exponents. All right, so this one has our coefficients. So I'm going to pull out my -2 and my -8. So it's going to be -2 times -8. Okay, these are still being multiplied together. And then I have my m, which is m to the 1st, because m is the same as m to the 1st, times m to the 5th. All right, so we have -2 times -8 is 16. And then we have m, and we add 1 plus 5. So we're going to have 16m to the 6th. The population of Grovetown is 6 to the 5th. The population of Putnam is 6 to the 3rd times as great. How many people are in Putnam? So we would take 6 to the 5th times 6 to the 3rd. We would add 5 plus 3 together because our bases are the same, which is 6. So we have 6 to the 8th. The Guadalupe River is 2 to the 8th miles long. The Amazon River is almost 2 to the 4th times as long. Find the length of the Amazon River. You can probably do this in your head by now. We know we're going to take 2 to the 8th, multiply it times 2 to the 4th. Because our base is 2, we're going to leave it as 2, and then we add 8 plus 4 together, so we get 2 to the 12th. All right, if we have negative powers, we actually do the exact same thing, we just do it with our negative numbers. So there's 2 different ways that you can look at this and think of it. So if we have x to the 4th times x to the -2, we do the exact same thing because they have the same base. So we take x and then we add 4 plus -2, and 4 plus -2 is 2, so we end up with x squared. Okay, if you think of x to the -2 as, well, x, I'm going to write it up here. X to the -2, remember, is the same as 1 over x squared. And 1 over x squared is 1 over x times 1 over x. So that's where they get this 1 over x times 1 over x. That's x to the negative 2. X to the fourth is x times x times x times x. 4 x's. Okay? Well, if we have, so I'm going to rewrite this right here actually. X times x times x times x, and then if we're multiplying it, because all of these would be over 1, so then these would be on our numerators and these would be our denominators. So it would end up being x times x times x times x over x times x, because these would be on the bottom. So then these would cancel out because x over x is just 1. So we would be left with x times x, which is x squared. They wrote it a little bit differently, but that's how I think of it, as like that. All right, so 3 to the 8th times 3 to the negative 2. 3 is our base. It's the same base. 8 plus negative 2 is 6, so 3 to the 6th. N to the 9th times n to the negative 4th. 9 plus negative 4 is 5, so n to the 5th. Now we have 5 to the negative 1 times 5 to the negative 2. So we would take 5 and we would go negative 1 plus negative 2, which is negative 3. But then notice that it says express using positive exponents. So 5 to the negative 3 is the same as 1 over 5 to the 3rd, or 5 cubed. So remember, a negative exponent is the same as 1 over that number to the exponent positive. Alrighty, so make sure you go on to NICU and take the 10-5 NICU quiz and have a super evening.